Hi, this is Lindsay Beagle, and today I'm going to talk about the regulation of sperm maturation in the germinal epithelium. First, I'm going to go over a review of the male reproductive system. There is external genitalia and internal genitalia. The external genitalia consists of the penis and the scrotum, and the internal genitalia consists of the seminal vesicle, the prostate gland, and other accessory glands and ducts. The gonads are the testes, which are contained in sac-like structures called the scrotum. Inside the testes, there are seminiferous tubules. That is the actual site of sperm production. And then sperm maturation and storage occurs in the epididymis, which eventually runs into the vas deferens and out of the urethra. So the testes here are in ovoid structures that have a capsule that includes a fibrous outer capsule that encloses these seminiferous tubules, and these seminiferous tubules then join with the epididymis, and so the sperm are produced in the seminiferous tubules and then go into the epididymis where they're stored and gain their motility and fertility, and then can be removed via the vas deferens. So these seminiferous tubules here, you can see a cross-section of them. Here we can see the interstitial cell that is, these are in between the different tubules, and they contain some late egg cells and a capillary, and then you have here the actual tubule itself, which I will talk a little bit more in detail. So the seminiferous tubule, this again is the site of sperm production. It contains two types of cells. We have the spermatogonia, which is the germ cell that undergoes mitosis and then meiosis to become a mature sperm, and spermiogenesis to become a mature sperm. And then you have your serotoli cell, which is a cell that regulates sperm development. There are three compartments in this tubule. You have your tubule lumen, and you have this basal compartment. You have your basal lamina, and on the outside here we have our interstitial fluid that contains things like the late egg cells. Inside of this compartment, you can see we kind of have these columns forming of the spermatogonium, and these are the columns that, as the meiosis and the mitosis occurs, the more mature sperm are towards the lumen, and in between these columns we have these regulatory sertoli cells. So spermatogenesis is going from your germ cell to mature sperm, and here we have the spermatogonium, which is diploid and goes through mitosis, and in mitosis it's going to result in two identical daughter pair. Now, one tends to stay behind to replenish, and the other one will go, the primary spermatocyte will go through meiosis 1, where it'll differentiate into a secondary spermatocyte that has one copy of each of the 23 chromosomes. It will then differentiate in meiosis 2 into 4 spermatids that each have one copy of the 23 chromosomes. And spermiogenesis then is the process in which these spermatids that do have the things necessary to become a mature sperm can then mature and become a sperm that is eventually motile and fertile. Now here we see the movement of these cells in the seminiferous tubule. You have, again, this spermatogonium that's near this basal lamina, and as meiosis and mitosis occur in this maturation, eventually you have the spermatid and eventually your sperm in the lumen, it goes towards the lumen, and this is so that it can then be moved into that epididymis where it can gain its motility and its fertility, and then go out through the vas deferens and be stored in the epididymis and out through the vas deferens. And I thought that this was a neat slide showing the movement throughout these divisions, how you have the spermatogonium that then goes through mitosis and produces that primary spermatocyte, and you can see that it's moved from here to here, away from that basal lamina. And then it goes through that meiosis 1 and becomes a secondary spermatocyte, and then the differentiation from meiosis 1 and meiosis 2, and you have these spermatids, these 4 spermatids again. And you can see the difference going from the spermatogonium to the spermatids that are close to the lumen of these seminiferous tubules, and then eventually going through spermiogenesis and becoming the spermatozoa in the lumen, which again can then leave and gain its motility and fertility in the epididymis and go out through the vas deferens. So the hormonal control. How is this process controlled? Well, testosterone is a big player in all of this, and here's how everything happens, and there's a nice negative feedback loop, making sure that the whole thing is controlled nicely. So the hypothalamus, we have the releasing of the gonadotropin-releasing hormone, and this stimulates the anterior pituitary to secrete 2 hormones. One is your LH luteinizing hormone, and the other one is your FSH. Here it's giving the FSH secreting cells and the LH secreting cells that secrete your luteinizing hormone and your follicle stimulating hormone. So your follicle stimulating hormone is going to directly be directed at those Sertoli cells, where it's going to stimulate spermatogenesis. Now, your LH over here, your luteinizing hormone, is going to target those Leydig cells that are in that interstitial fluid in between those seminiferous tubules. And the Leydig cells, their job is to secrete androgens. And the androgen in this case is going to be testosterone. So testosterone is a very important androgen. And testosterone is going to bind to androgen receptors in specific target tissues that can be responsible for other things, such as secondary male characteristics and things like that. And testosterone is also going to target these Sertoli cells. So in addition, FSH is also stimulating these cells, and they're going to release an androgen-binding protein. So in this case, the testosterone is really going to increase. And when we have this spermatogenesis get to a level, a certain level, the Sertoli cells are then going to release inhibin. And here is now we're going to have this negative feedback. So inhibin is going to go back and negatively inhibit the FSH release, and we're going to have testosterone go back in a negative way, and go back and inhibit at the anterior pituitary the LH secretion of secreting cells, and then also go and inhibit the hypothalamus. And this is just to maintain a control over how much sperm are being produced at a given time. So spermiogenesis, we have this part where we got to these 4 spermatids that are immature sperm cells, but still incapable of fertilization. But those immature spermatids did contain numerous cell bodies, like the Golgi body, the centrioles, and mitochondria, and they undergo the spermiogenesis to form a functional sperm. Now, spermiogenesis is divided into 4 stages. We have our Golgi phase, the cap, the tail addition, and the maturation. So in your Golgi phase, this is where the Golgi body present in the spermatid forms the enzymes for the acrosome. And the second phase, which is basically the acrosomal phase, you have this acrosome is where the formed acrosome condenses around the nucleus to form this cap. The third phase is the tail phase, where the centriole present in the spermatid forms the tail. And the last is the maturation phase, where the spermatid loses the excess cytoplasm and forms the mature sperm. So these are still not motile, but what they do is then they enter the epididymis, and the epididymis will then it'll stay there for a little while and form these mature sperm that are motile and able to fertilize. And then smooth muscle contractions and things will move these down through the way and eventually out via the vas deferens. So that is going from a spermatogonium all the way through to the part where we get to the vas deferens and the hormonal control and the maturation of the sperm. Thank you.